Hi folks, today we're talking about lines that intersect circles. We are moving into a new unit about circles. We're still going to talk a little bit about triangles, but they're not going to be the center of our focus for the next couple of weeks. But we are going to be talking about circles, so if you haven't done so already, please take out a sheet of notebook paper. Because we can't make copies, we're going to make do with what we have. And we're going to copy down our notes on notebook paper today, and we'll glue them in a few days. So please take out a sheet of notebook paper, title it Lines That Intersect Circles. I have my notes today taking up one full page of my notebook paper, and I have most of my notes already written down, but some of the things you'll see are kind of covered up, and those are going to be the diagrams. And I'm going to draw the diagrams with you so that you understand how to draw them. Typically, we would have some kind of like circle to trace so that we know that our circles are nice and precise. Maybe we would take out the compasses, but because you have a substitute today, we're just going to be kind of freehanding our circles. So best of luck to you if you're not an artist. I'm not the best artist, but I feel like I can draw a circle. So our lines that intersect circles notes are all about just that. They're about different kinds of lines that can intersect circles. So before we discuss some of our key terms, which is what most of our notes are, this set of notes is very much about vocabulary and what that looks like in a diagram. So before we start, I want you to draw a picture up in this kind of top right corner. I want you to draw a circle as best as you can. Okay. A circle as best as you can. Erase any like extra part like I have from where your circle started. And I'm going to ask you to draw a couple things with a straight edge. Like I'm going to ask you to draw points A and B. And I'm going to ask you to connect them. So you kind of have segment AB there. I'm going to ask you to draw a line through your circle. Please don't try and make it the diameter. Don't try and make it go straight through the center. I'd like for this to be something that's not going through the center so that you have it as an example. It doesn't really need points along the circle, but we're going to call this line L. And then finally, maybe kind of down here somewhere, I want you to go ahead and draw in point C. And point C is going to have a line going through it as well. It's going to be touching the circle. Please make sure that your line is kind of not touching it like down here, but really touching it only at that point C. Only at that point C. So it's going to look kind of like that. And we're going to call this line M. In addition to that, I want you to try to shade in, not real dark, because if you do it real dark, you're not going to be able to see everything, but I want you to shade in this circle, because we're going to talk about this shaded area a little bit. So kind of shade that in. You want to use a pencil and blend it. Now it looks nice and shaded. So here are, here's our diagram, and our key terms are off to the side, and I'm going to talk about them as you copy them. Feel free to pause the video as you need to copy the key terms if I'm writing faster than you read. So number one, we need to talk about the interior of a circle. And the interior of a circle is the set of all points inside the circle. So all this shaded stuff that you just did, that's all in the interior. Points A, B, and C are on the circle. They're not in the interior. Maybe point D, that's on the interior of the circle. So that's an interior point. An exterior, the exterior of the circle, it's the set of all points outside the circle. So points A, B, C, and D are not in the exterior, but point E is. So that's the set of all points outside the circle. That's the exterior. The next word is a chord. You may think of a chord like a piece of rope, a piece of string. You might think of a musical chord. This chord is a segment whose endpoints lie on a circle. So if you look at your diagram If you find the one segment that we drew whose endpoints are actually on the circle, that's segment AB. This is our chord. Okay, segment AB is our chord. Remember that when we write a segment, we write the two endpoints and we write a bar on the top, indicating that it is a segment. The next key term is a secant. A secant is a line. It's not a segment, it's a true line that intersects a circle at 2 points. So if segment AB continued on and on in both directions, then that would be a secant. But because it has endpoints on the circle, that's a chord. The secant that we see is line L. Line L is a line, and it intersects the circle at 2 points, right here and right here. So our secant is line L. The tangent, which we've heard before, right? Sine, cosine, tangent. Tangent is a trigonometric function, and it's equal to, the tangent of an angle is equal to the opposite side over the adjacent side in a triangle. But here in a circle, a tangent has a different name, or a different definition. It's a line, again, in the same plane as the circle. So if I draw the circle on paper, it's a line on that paper, and it intersects it at exactly 1 point. So the line that intersects our circle at only 1 point, like point C, is line M. Line M. So this is our tangent. Line L was our secant. And segment AB was our chord. Now, something else we want to discuss is the point of tangency. And the point of tangency is exactly what it sounds like. It's the point where a tangent and a circle intersect. So remember, a tangent is where a line touches the circle at only 1 point, exactly 1 point. Well, that 1 point is called the point of tangency, and here that would be point C. Okay, that's our point of tangency. So I'm going to go ahead and move this up. These are our first few key terms, and we're going to have more. I'm going to move it up to, let's see, maybe about right there. There we go. So we can still see most of, there we go, most of our stuff. So in example 1, what I'd like for you to draw, and I didn't realize I didn't cover this, but I can go ahead and show you how to draw it. So you draw your circle. Okay, I want you to draw point A. Point A is the center of the circle. We're going to call this circle A. Through point A, I want you to use your straight edge, and I want you to draw a secant from B to C. Okay, go ahead and label it point B, point C. I also want you to draw a line going through point C, but only touching at one place. And then you can use your straight edge to draw another line somewhere down here. And you can give it points E and F where it touches the circle. So if you need a moment to copy that diagram, go ahead and pause your video and copy it. We're going to be finding the chords, the tangents, the secants, the radii, and the diameter. So pause your video and try to fill in all of those pieces. All of those pieces. Pause your video. Fill in those pieces. Okay, so for chords, remember that a chord is a segment whose endpoints lie on a circle. And an example of that was right here. So a segment, endpoints on the circle. So looking at our example 1, the only part that has a segment with endpoints on the circle is right here, right? Point B to point C. That's our segment. So segment BC. Now sometimes students argue that there's another chord in here, and technically there is, it's just not explicitly shown as a chord. Where's the other segment? Well, it's from here to here. It's included in line EF, and it's segment EF. So segment EF is part of line EF, but I can just write that segment EF is another chord, and that's acceptable. For tangents, remember that a tangent is a line in the same plane as a circle, so it's on the same diagram. that intersects it at exactly 1 point. So it can only touch, the line can only touch the circle at 1 point, and that would be right here. That's line L. It is the only tangent that we can draw, or that we can write from this drawing. Next up is a secant. It's a line that intersects a circle at 2 points. So a line that's going through the circle at 2 points. The only line that does that is line EF. It's a line, because it's got arrows, it's going through the circle at 2 points. So line EF. Remember when we write lines and we name them, we write the 2 endpoints and we put the arrows at the end. The radii, remember the radii is just the plural form of the radius. The radius is the distance from the center of the circle to the circle itself. So from here to here, or from here to here. So we have 2 radii that we can name. We can name segment AB, this radii. We can name segment AC, this radii. And then the diameter is all the way across going through the center. That's important. So the diameter is not EF, because that does not go through the center of the circle. This is the center of the circle. So the diameter here is segment BC. And remember that the diameter and the radius might refer to the actual segments, like the pictures, but it might also refer to the length of the radius or diameter in the picture. So radius and diameter could either mean the figure or the number. It just depends on the context. So keep that in mind. So I'm moving on down to some more key terms. We're going to talk about different kinds of circles, or pairs of circles here. So moving on down, this is the last little bit of our notes. I don't have anything under this, so the rest of our notes is going to be these key terms and the diagrams. So you can pause your video at any time so that you can draw or so that you can catch up and write if I'm talking too quickly for you. So we want to talk about pairs of circles, and circles can do lots of different things. We can have congruent circles. So congruent circles look like this. So I want to draw 2 circles. Obviously, I want them to look the same. So try to make them look the same. Okay, they look kind of ish the same size. I'm going to put centers in them and draw a radius from each one. Okay. So congruent circles, 2 circles are congruent circles if and only if they have congruent radii. So maybe this is circle A and point C is on the circle, and maybe this is circle B and point D is on the circle, and if these 2 radii are congruent to each other, then I have congruent circles. So I have congruent circles if and only if the radii are congruent. Now there's such a thing as concentric circles. Concentric circles, if I break that down, the prefix con means with, and then centric kind of means center. So that means that the 2 circles have the same center. So here's the center of my circles. Maybe I have this circle with this as my center, and then maybe I have a bigger circle with that as my center. It almost looks like a bullseye, like if you're playing darts, right? There's the center. So those are concentric circles, circles that share the same center. And then finally we have tangent circles. Remember from before that tangent meant that it was only touching at 1 point. So a tangent was a line touching a circle at only 1 point. Well, tangent circles only touch each other at 1 point. So if I have a small circle right here, perhaps I have a larger circle that's only touching at 1 point, and its center is here, and here's its point of tangency. Finally, it's also possible that I have tangent circles that are not one inside the other. Maybe they're touching each other, but they're outside of each other. So maybe I have a small circle here with the center, and maybe I have a bigger circle here with the center only touching at 1 point of tangency. Now, it's possible that we have a common tangent. So we're kind of talking about tangent circles and how it's kind of like a tangent where it only touches at one point. But a common tangent is a line that is tangent to two circles. So if we're talking more about pairs of circles, it's possible that we have a common tangent. So a line that's tangent to both of them at the same time. So we can have externally tangent or internally tangent. So for externally tangent, I want you to go ahead and draw two circles. They can be different sizes if you wish. And remember that tangents will only touch at one place, so I want you to use your straight edge. And I want you to touch the circles at only one place and draw your tangent. Okay, so maybe line L, maybe down here, touching only at one place on the circle. Maybe line M. So these would be considered common tangents. Line L and line M are lines that are tangent to two circles. And they're externally tangent because they're on the outside of the circles. Now we have internally tangent. So when we have internally tangent, go ahead and draw your two circles again. And again, they can be different sizes. Okay. Draw your two circles with their centers. And to be internally tangent means that they're not just touching on the outside, they're touching and they're kind of crossing in between the circles. So kind of like this. You want to line it up so that your lines are only touching the circles once. So perhaps this is line P. Notice how it's only touching the circle one time here and one time here, and then you can make them cross this way as well. So taking your straight edge and drawing another tangent. Maybe the second line is line Q. So only touching at one place, only touching at one place. And these are considered internally tangent. So tomorrow we'll discuss a little bit more about lines that intersect circles. We'll talk a little bit more about circle pairs, but today you got a lot of the terminology. So if you will keep this with you, we'll expand on this tomorrow. Have a great day, folks. Bye.